Now this is interesting because it shows a deep misunderstanding about what science actually is. You see, science isn't about proving what's possible and impossible. That's not the business of science. The business of science is to say what's more likely and what's less likely. And to do that, you need to understand something about how the world actually works. You need to understand the laws of nature. So let me ask you something. If intelligent life exists somewhere out there in the universe, and I think it probably does, the universe is so vast and life emerged on Earth almost as soon as the laws of physics and chemistry allowed. If they exist, what would happen if they tried to visit us? That's the question, not whether they exist, but what would it take for them to get here? Now this is where physics becomes a prisoner. You see, the laws of nature aren't just suggestions. They're not something you can negotiate with or get around. They apply everywhere, to us here on Earth, to any aliens out there, to everything in the universe. And that's a very important point to understand, because once you accept the laws of physics, you're accepting some very serious constraints on what you can do. Let me talk about space first, because space is the first problem. The nearest star to us is about 4 light years away. 4 light years. Do you know what that means? It means that light, the fastest thing we know of, takes 4 years to travel from that star to here. Now, if you wanted to build a spacecraft and go to the nearest star and come back, you have a problem right away. You would have to travel at some significant fraction of the speed of light. Otherwise, the journey would take thousands of years. Now, who's going to build a spacecraft that takes thousands of years? You might say, well, maybe these aliens have some technology we don't have. They can figure out something we can't. Okay, let's think about that. Let's think about what the laws of physics say about getting a spaceship to near light speed. Imagine you want to accelerate a spacecraft from 0 to, say, half the speed of light. Just to pick a number, well, to do that you need fuel, and the fuel has to do work. It has to accelerate the spaceship and everything in it. Now, there's a beautiful formula in physics that tells us something about this. The relationship between energy and mass, E equals mc squared. This is one of the most important discoveries about nature. It tells us that energy and mass are connected, and it tells us something else. When you convert energy into motion, the amount of energy you need is enormous. And here's the thing about rockets. A conventional rocket, a chemical rocket, has to carry all of its fuel with it. All of it. The fuel has mass, so you have to accelerate the fuel as well as the spacecraft. So you need more fuel, but that fuel has mass too. So you need even more fuel. And suddenly you realize that to get a spacecraft up to even a reasonable fraction of the speed of light using a conventional rocket, you need an amount of fuel that is greater than the mass of the entire visible universe. That's not a metaphor. That's the actual calculation. Now you might say, okay, but maybe they have a fusion engine. A nuclear fusion engine is much more efficient than a chemical engine. It can release far more energy per unit of mass. So maybe they're using that. Okay, let's allow for that. Even with nuclear fusion, which is incredibly efficient, much more efficient than what we can do here on Earth, even with that, you still need more than 2,000 times the mass of the spaceship in fuel just to accelerate it to near light speed and then decelerate it when you get there. 2,000 times. Do you understand what that means? That means if they have a spacecraft the size of, say, a large building, they would need 2,000 times that much mass in fuel. The fuel alone would be like a small planet. And to move that amount of mass, you would need an amount of energy comparable to all the energy that all of humanity uses right now. All of it in one trip. Now, an advanced civilization might have that energy available. I'm not saying it's impossible, but I'm saying it's a very severe constraint. And that's what I mean when I say aliens are prisoners of physics. They're constrained by the same laws that constrain us. Let me think about this another way. Let's say there's a civilization out there. They're very advanced, much more advanced than us. They have figured out how to harness the energy of their star, maybe even the energy of their entire solar system. And they decide, let's go visit Earth. Let's see what's going on there. They build a spaceship, a beautiful spaceship, the best engineering they can manage, and they equip it with their best fusion engines. And they accelerate toward Earth. And because they're smart, they figure out a way to get to half the speed of light. Maybe they've even figured out how to harness some exotic physics that we don't understand yet, but they still have to obey energy conservation. They still have to follow the laws of thermodynamics. They can't just invent energy. And with all of that, the energy cost of the journey is staggering. Now, when they get here, they want to slow down. They don't want to just zoom past Earth at half the speed of light, so they have to decelerate. And guess what? Deceleration takes the same amount of fuel and energy as acceleration. So now we're talking about twice the amount of energy, twice as much fuel. The numbers get even worse. And here's another thing I want you to think about. If they're coming from, say, a star in the region of Vega or Sirius or any of the nearby stars, they've already traveled 4 or more light years. 4 years of travel, even at half the speed of light. And they had to accelerate for part of that journey, coast through the middle, and decelerate at the end. The amount of energy we're talking about is almost incomprehensible. It's the kind of energy that can reshape worlds. It's the kind of energy that can boil oceans. So now I want to ask you something. If a civilization had that much energy, that much power, what would they do with it? Would they really spend it on a sightseeing tour to Earth? Would they really spend it to visit a species that's barely figured out how to split the atom? Think about the mathematics of it. To make an interstellar trip feasible, you would need an incredibly powerful reason to do it. And the reason would have to be something that you couldn't do at home, something that you couldn't do with your own star or within your own system of planets. What would that be? Maybe they want to conquer us. Maybe they want our resources. But our resources are not particularly special. Iron and silicon and carbon and water, these things are all over the universe. You can find them anywhere. There are probably 1 million planets around nearby stars that have the same resources that Earth has. Why come all the way to Earth? Maybe they want to study us. Maybe they're interested in biology, in how life works. That's a possibility. But if that's true, they would send small probes. Maybe they would send a radio message asking to visit. They certainly wouldn't send crewed spacecraft. The energy cost would be too high. Now, I want to talk about something else that bothers me about flying saucers, and that's the evidence itself. You see, people claim to have seen flying saucers all the time. And when you look at these claims, you notice something very interesting. Almost everybody who observes a flying saucer sees something different. One person sees a round, flat thing. Another person sees a gray fog. Another person sees gossamer-like streams in the sky. All supposedly the same event. All supposedly the same object. But everybody describes it differently. Now that's very strange, because if you're observing the same physical object, even if the observers are at different angles or different distances, they should still see roughly the same thing. A disk is a disk. A light is a light. But no, these objects are incredibly variable in appearance. On the other hand, when something really does visit Earth in a way we can measure and record, we see consistency. When meteorites fall from space, they all look like meteorites. When spacecraft enter the atmosphere, they all look like spacecraft. There's a pattern, there's a consistency. But flying saucer reports, no consistency, which tells me something. It tells me that what people are seeing are not actual physical objects from space. It tells me that what people are seeing are probably a combination of things. Maybe some people are seeing unusual meteorological phenomena. Maybe some are seeing reflections of sunlight on clouds. Maybe some people are seeing aircraft at odd angles with unusual lighting. Maybe some people are having subjective experiences that feel very real, but are not actually observations of external physical objects. There's actually interesting research on this. There's a phenomenon called sleep paralysis where people wake up but they're paralyzed and they experience very vivid sensations of alien presences, of being abducted, of being removed from their bodies. All of these are subjective experiences that feel completely real to the person having them. But they're not external events, they're neurological phenomena. So the inconsistency in flying saucer reports, to me, is evidence against flying saucers, not evidence for them. Because if an alien spacecraft actually landed in your town, I would expect you to describe it accurately. I would expect consistency across witnesses. I would expect physical evidence, and we don't see those things. Let me return to the physics, though, because that's the real point. The point is not whether I believe in flying saucers or not. The point is that the laws of physics place severe constraints on what's possible. And those constraints apply to everyone. They apply to us, and they apply to any aliens out there. Now, there's something called the Fermi paradox. You might have heard about it. It's a simple question. If intelligent life exists in the universe, and if some of that life has become advanced enough to travel between stars, then where is everybody? The universe is billions of years old. There are billions of galaxies, and each galaxy has billions of stars. The math suggests that life should exist in many, many places, and some of that life should have had billions of years to develop and to explore. So where is everybody? Why haven't we detected any alien civilizations? There are lots of possible answers to that question. Maybe intelligent life is incredibly rare. Maybe civilizations don't last very long. Maybe there are physical barriers to interstellar travel that even advanced civilizations can't overcome. And that last one is interesting because it goes back to what I'm saying about physics. You see, the Fermi paradox is sometimes presented as a mystery, but I don't think it's a mystery at all. I think the answer is pretty straightforward, And the answer is that the universe is vast, and space is deep, and the laws of physics place severe limits on what you can do. An alien civilization might be incredibly advanced. They might have solved every engineering problem that we have to solve. They might have figured out technologies that we can't even imagine, but they still have to obey the conservation of energy. They still have to obey the laws of thermodynamics. They still can't travel faster than the speed of light, at least not with any known physics, and I don't know of any good reason to think that light speed is not the ultimate speed limit. So here's what I think. I think that an advanced civilization might exist somewhere out there in the universe. I think it's actually probable, given how vast the universe is and how much time has passed. But I also think that the physical constraints on interstellar travel are so severe that that civilization is probably very far away, thousands of light years away. Or maybe they're in a different galaxy. And the cost of sending a spaceship here is so high that they would never do it. They might send radio signals. They might listen for radio signals from us. But they wouldn't send a spaceship. The energy cost would be too high. It would make no sense. And even if somehow they did send a spaceship, even if somehow the laws of physics were wrong and there's some loophole that I don't know about, the spacecraft would arrive here once, maybe, in all of human history, not repeatedly, not so that it leaves physical traces and videos that we can analyze, once, if that. If. This is what I mean when I say aliens are prisoners of physics. They're constrained by the same laws that we are, and those laws are not kind to the idea of casual interstellar travel. Now, I want to shift gears a little bit, because I don't want to leave you with the impression that I don't think about aliens. I do. I think about it a lot, actually, because the question of whether life exists elsewhere in the universe is a fascinating question. It's a question about the nature of life itself. Here on Earth, life emerges pretty quickly once the conditions are right. The Earth formed about 4.5 billion years ago, and life appeared within the first 500 million years or so, maybe even sooner. So it seems like life is not some incredibly rare accident. It seems like life is something that emerges naturally when you have the right chemical ingredients and the right amount of time. Now, those chemical ingredients are everywhere in the universe. Water, organic carbon, nitrogen, phosphorus, all of these elements exist in abundance. They're in the interstellar dust, they're in comets, they're probably in the atmospheres of many planets. And the laws of chemistry are the same everywhere. So if life emerged on Earth because of the laws of chemistry and the availability of certain molecules, then it should emerge on other planets too. It probably has. So I expect that intelligent life exists somewhere in the universe, maybe in many places. But I also expect that they are very far away from us. And I expect that the laws of physics prevent them from casually visiting. Those laws are fundamental. They're not negotiable. And here's the thing that fascinates me about this. It's that even if an alien civilization achieved incredible technological sophistication, even if they harnessed the power of their star and understood physics better than we do, they would still face the same fundamental problem. They would still be prisoners of the laws of nature. They can't escape those laws any more than we can. This is actually one of the most important lessons that physics teaches us. The laws of nature are not obstacles to be overcome. They're the rules of the game. They apply everywhere. They apply to everything. And understanding those laws and accepting the constraints they impose is essential to understanding what's possible and what's not. You see, there's a tendency in people, a very human tendency, to imagine that advanced technology can do anything. That if you're smart enough, if you're advanced enough, then anything is possible. But that's not how it works. Advanced technology can do some things better than primitive technology, but it can't violate the laws of nature. It can't create energy from nothing. It can't make matter travel faster than the speed of light, at least not with any physics we understand. So when I think about aliens, I think about this constraint. And I think it's actually a very interesting constraint because it tells us something about what we should expect to find in the universe. If we ever do find evidence of extraterrestrial intelligence, I would expect it to take the form of radio signals, not spacecraft, radio signals, because radio communication is cheap, energy-wise. You can send a signal using far less energy than you would need to send a spaceship. That's the thing we should be looking for. That's the realistic scenario. And if we ever do receive a radio signal from an alien civilization, what a moment that would be. What an incredible moment for science and for humanity. But I think we should be realistic about what that signal would tell us. It would tell us that intelligent life exists elsewhere. But it wouldn't mean that the aliens are coming to visit. It would just mean that they're there, somewhere, far away, listening like we are, trying to understand the universe. Now, let me just touch on something else because I think it's important. Some people claim that the government knows about aliens and is covering it up. They claim that there are UFOs in secret hangars being reverse engineered by scientists. They claim that the government has made contact with alien civilizations and is keeping it secret. And I'm always amazed by these claims because they seem to require more of an explanation than the simplest explanation. You see, for there to be a secret alien spacecraft in a government hangar, there would first have to be an alien spacecraft. And we've already established that the energy cost of getting a spacecraft here is enormous. The probability of that happening is extremely low. So the claim that the government has a spacecraft is less likely than the claim that there are no aliens visiting Earth. Also think about it logically. If the government really did have an alien spacecraft and they really did understand how it worked, do you think they would keep it secret? They would want to figure out the technology. They would want to understand the propulsion system. They would want to understand the weapons. And that means they would need the best scientists in the world working on it. And if the best scientists in the world are reverse engineering an alien spacecraft, some of them are going to talk. Some of them are going to publish papers. Some of them are going to share what they know with others. That's how science works. And we don't see that. We don't see any credible scientific evidence that the government has reverse engineered anything. So I'm skeptical of those claims too. Not because I'm closed-minded, but because I'm paying attention to what would actually happen if those claims were true, and what I would expect to see if they were true, and I don't see those things. Let me step back for a moment and think about what we should really care about when we think about aliens and physics and the laws of nature. First, there's the question of whether life exists elsewhere in the universe, and I think the answer is probably yes. The universe is vast. The laws of physics and chemistry are the same everywhere. The ingredients for life are everywhere. So life probably exists in many places. That's a pretty conclusion, I think. Second, there's the question of whether we will ever make contact with that life. And I think the answer is probably no, at least not in the near future. Not unless we figure out how to send radio signals or receive them, and not unless an alien civilization is close enough and advanced enough to do the same. The distances in the universe are enormous. The time scales are enormous. The probability of two civilizations developing at roughly the same time in roughly the same place in this vast universe is extremely low. Third, there's the question of how we should think about constraints in physics. And I think this is the most important one, because understanding constraints is what science is all about. It's about understanding what's possible and what's not possible. It's about understanding the rules of the game. And once you understand the rules, you can ask better questions. So when you think about aliens, don't ask, are they visiting us? Ask instead, how would they visit us? What would it cost in energy? What would it require? And is that actually probable? And then you can work from first principles. You can work from the laws of physics. And you'll find that the answer is very different than what the flying saucer enthusiasts might suggest. You know, I've often thought about this question of how to detect an alien civilization if they were trying to communicate with us. And it's a fascinating problem because it gets at the heart of what you could know about something if you only had limited information. Imagine you're trying to explain to an alien civilization over the radio what human beings look like. You can't send images. You can only send numbers. What would you do? Well, you might start with basic integers. You might establish a numbering system, and then you might start to describe size and shape. You might describe a height relative to the wavelength of hydrogen, which is the same everywhere in the universe. And then you might get to the tricky part. You might say, now we have a heart, and it's on the left side of our body. And the alien asks, which side is the left side? Now you have a real problem. How do you define left and right over the radio? How do you describe your own handedness to something that might have completely different symmetries, completely different biology? And it turns out there's only one way to do it. You have to reference a phenomenon that has handedness built into it, a phenomenon where the laws of nature themselves prefer one direction over another, and that wasn't known until 1957. Before that, physicists thought that the laws of physics were completely symmetric. Left and right were indistinguishable. But then a wonderful experiment was done, and it was discovered that at the subatomic level, at the level of beta decay, nature does prefer one direction over another. So now you could tell an alien over the radio which direction is left. You would do an experiment, you would describe the experiment, and you would ask the alien to do the same experiment, and they would see the same asymmetry that you see. And from that asymmetry, you could both agree on what left and right mean. This is the kind of problem that would come up if we ever made contact with an alien civilization. And it shows that even the simplest communication would require understanding of fundamental physics. It would require both sides to understand the laws of nature in detail, and it would require both sides to be able to do experiments to verify what they're claiming. So this is another constraint on communication with aliens. It's not a limitation of energy or distance. It's a limitation of what you can meaningfully convey to something that might think completely differently than you do. You would have to find common ground in the laws of physics themselves. I think about this often. I think about what it would mean to have a conversation with an intelligent being that evolved on a different planet in a different solar system under different conditions. What would be the same? What would be different? And I think the answer is that the laws of physics would be the same, the laws of chemistry would be the same, but everything else might be different. Their biology would be different, their psychology might be different, their values might be different, their history would certainly be different. And yet, despite all those differences, you could still have a meaningful conversation because you could reference the laws of physics. You could both point to the same physical laws and say, here, this is true. We both know this is true. Let's build from here. So in a funny way, the laws of physics are the only universal language. They're the only thing that would be the same across the universe for every civilization, no matter how different they might be. And that's what I mean when I say aliens are prisoners of physics. They're not just constrained by physics in practical terms. They can't easily travel between stars. They can't build perpetual motion machines. They can't get free energy from nowhere. They're also constrained by physics in a fundamental sense. Their entire understanding of reality is built on the laws of physics. Their technology is built on the laws of physics. Their ability to communicate across the stars would have to be grounded in the laws of physics. So when I think about aliens, I don't think of them as beings who have somehow transcended the laws of nature. I think of them as beings who, like us, are constrained by those laws. And that constraint is actually what makes them comprehensible. That's what makes it possible to think about them in the first place. Because if the laws of physics were different for them, if they obeyed a different set of rules than we do, then we couldn't predict anything about them. We couldn't say whether they could build spacecraft or send signals or do anything else. We would have no way to think about them at all. But because we share the same laws of physics, we can make predictions. We can say, if an advanced civilization exists and if they want to communicate with us across the vastness of space, then they would probably use radio signals because radio signals are the most energy-efficient way to send information across vast distances. We can reason about them, we can think about what they might do and why they might do it. So the laws of physics, in a sense, are the key to understanding anything about aliens at all. And if you accept that the laws of physics apply to them as well as to us, then you're forced to conclude that casual interstellar travel is probably not feasible, that visiting Earth would be an incredibly expensive undertaking, that it would only happen for the most serious reasons, and that it probably hasn't happened at all. This is not a limitation. It's not a sad conclusion. It's actually a liberating conclusion in a way, because it means that we don't have to worry about being invaded by aliens. We don't have to fear that our planet is being secretly visited and monitored. We can focus on the real questions. We can focus on whether life exists elsewhere. We can focus on how to detect it if it does. We can focus on understanding the laws of physics better, and that's really what it's all about. Understanding the laws of nature, accepting the constraints that those laws impose, and working within those constraints to figure out what's really possible. You know, I think the best way to end this is to come back to the beginning, to come back to that conversation about flying saucers that I had many years ago. Someone asked me, is it impossible that there are flying saucers? And the answer is no, it's not impossible. Nothing is absolutely impossible. There's always some probability, however small, that something could happen. But that's not really the useful question. The useful question is, how probable is it? And what would it require? And does that requirement make sense? And when you ask those questions, when you really think about the energy cost, the distance problems, the probability calculations, you realize that casual alien visitation to Earth is incredibly improbable. So improbable that you're probably wasting your time looking for evidence of it. But the search for other life in the universe, that's not a waste of time. That's a noble endeavor. That's something worth doing because it tells us about ourselves. It tells us about the nature of life. It tells us about the universe. And understanding the laws of physics, understanding how those laws constrain what's possible and what's not, that's not limiting. That's empowering because it gives you the tools to think clearly about the world. So remember this, aliens, if they exist, are prisoners of physics, just like we are. And that's not a limitation. It's a reminder of what we all share.